The imaginary number I is defined to be the square root of -1. If I is equal to the square root of -1, and then we square both sides of this equation, we would end up with I squared on the left, and the square root of a quantity squared cancels each other out, so we would have -1 on the right. So I squared is the quantity -1. Let's recall that if you have a real number quantity squared, that's always going to give you a positive quantity. So we define I to be what we call an imaginary number because it's a quantity that can be squared to yield a negative number. Let's look at an example. We're asked to evaluate the following quantity, the square root of -64. In order to do this, let's split the radicand into the factors of -1 times 64. Let's recall that when we have two things multiplied under a radical, we can split that radical over multiply. So because we have -1 times 64 under the radical, we can split this into the square root of -1 times the square root of 64. And now we can evaluate each of these individually. The square root of -1, as we saw, has been defined to be I. And we know that the square root of 64 is 8. So this is I times 8, and we actually prefer to have the coefficient 8 come before any letters, so we would call this 8I. Let's do that again in part B. We see that we have a radicand of -8, and that can be split into -1 times 4, which has a clean square root, times 2. So we're looking for the factors of the radicand that can be pulled out of the radical, or the factors that have nice and clean square roots. So because we have multiply underneath the radical, we can split the radical into the product of the square root of -1 times the square root of 4 times the square root of 2. And then we evaluate any radicals that can be evaluated. The square root of -1 is I. That's then going to be multiplied by the square root of 4, and the square root of 4 is 2, which is then multiplied by the square root of 2, and since that doesn't have an integer quantity, the square root of 2 is an irrational number, we would leave that as the square root of 2 so that our answer is an exact value and not a rounded off decimal. So what we end up with as the square root of -8 is going to be 2 times I times the radical 2. We just rearrange these elements so that the integer is first and the radical is last, which means that the quantity of I will be right here in the center. And so this is the preferred form of the square root of -8. So let's see that one last time. We start by splitting the radicand into the product of factors that have integer square roots. So this is going to be -1 times 25 times 5, and that product is -125. Because we have multiply under the radical, this radicand can be split so that we have the product of the square root of -1 times the square root of 25 times the square root of 5. So the original square root of -125 can be evaluated to be the square root of -1, which is I, times the square root of 25, which is 5, times the square root of 5, which does not have an integer quantity, so we just rewrite that down as the square root of 5 to keep our values exact. So now we have that the square root of 125 can be rewritten as the quantity where 5 comes first, the integer value will be first as the coefficient, the imaginary number will be behind that, and any radicals that remain need to be written last, essentially to ensure that nothing accidentally slips under the radical or looks like it's written under the radical when it shouldn't be. And so this would be our final answer.